Hi, I'm going to walk you through how to create a statistical outlier detection index in Power BI. So what I've done is created a dashboard here that has the ability to identify statistical outliers that is also dynamic. So on the left side, we are looking at users to a website. We have our percentage of outliers. We have the number of days that are in the range. And the range, by what I mean, is the range of values that we expect to have. And then we have the number of days with the outliers. This is all dynamic. And this outlier detection is based on percentiles, and we're able to dynamically change the percentile. For example, now we're looking at anything above a 95 percentile is identified as a outlier, and anything below the 10th percentile is identified as an outlier. And we can also see that in this dynamic narrative here. So if I move this, we can see I graph identify more outliers as I lower the threshold to the 75th percentile. This is also dynamic because it adheres to the dates also. And we can constantly raise or lower that upper threshold and that lower threshold. So I'm going to show you how to create that using DAX. So let's go and look at some theory first so we understand what we're doing. This is the formula that we're looking at. We're using a statistical outlier formula which uses quartiles, and you can also see that it has the minimum barrier, which is based on the quartile formula here, and the maximum barrier, which is based on the quartile here. This corresponds to the percentiles that we had in the previous dashboard. And also you can set this up with standard deviation, which you see here at the bottom. Now, if we're looking at our data, we have data that is time stamped, that is just user data to a website, and we want to be able to identify the days that we have an outlier using this formula. So we can easily find the first quartile, which is the 25th percentile, and the third quartile, which is the 75th percentile. Then we can calculate our IQR, and then we can create this formula. So if we quickly visualize some data, because it's very hard to understand where outliers are just looking at a table, but it's always good to do a little bit exploratory data analysis through visuals. We're going to use a scatter chart, and we're just going to put our users on the x-axis and the y-axis, and then we're going to get some granularity through the date, which is the day index here. And we can see that we have some outliers here and some outliers here. So let's create some DAX that adheres to this formula. I've created a lot of these measures, so we can identify our first quartile just by getting the 25th percentile. And the way we do that is through the percentile formula. There are two types of percentiles. There's percentile, and let me just show you here. So we have the percentile.exe, and we also have percentile.inc. There's a very subtle difference between the two. You might have to change this to adhere to your particular data set. I'm going to use EXC for my data set, and we also have the ability to have iterator functions with this, so the percentile X functions. So I'm just going to use EXC, and it asks for a column, and then you identify the particular percentile. So that's our Q1, quartile 1. I'm just going to bring that value in as a card so we can see what it is. And then let's bring in a card for our quartile 3 so we can see what that is. And then I'm going to give you our quartile 1 just by changing this. Now we need to calculate, according to our formula, the IQR. And I have that done here. And all that is going to be is quartile 3 minus quartile 1. We turn that into a card. And now we have our IQR. Now let's set up the formula here and here to find out what our values are. And then we'll understand the pros and the cons of using this method. So I'm going to create that formula just going over, right clicking, using new measure. So let's replicate the maximum by saying quartile 3, Q3, plus 1.5 times our IQR. And we know this is our maximum. So let's bring the maximum in, change that to a card. Now we know anything above 3.23 is going to give us our outliers. Now let's get our minimum. Right click, go to new measure. We're going to use the minimum, and then we're going to identify an issue here that we're going to contend with. 1.5 minus 1.5 times IQR. And we're going to call this our minimum. And let's bring in our minimum. And wow, we have a negative minimum. Now we're very aware that our data set is not going to have minimums that are negative. So we might have to change the sensitivity of or the method in which we calculate our outliers for our particular data set. But let's use a traditional formula, and I was able to calculate all these independently, but we can use the outlier. So now we can put all this in one formula so we can identify outliers. So I have an outlier formula here, and I've used variables to bring all that into one formula. So in my outlier formula, I have IQ3, and you can see there's a difference here. We calculate it the same way, but I use the iterative function, and we're getting all, so I use the all function, so I can identify all the outliers regardless if we change the dates or any filters are applied. So I got my Q3, Q1, we created our IQR, we created our upper limit and our lower limit, and then I used a conditional. Instead of if, I chose to use the switch function, which says if this is true and the selected value is above our maximum or lower than our minimum, give us the word outlier, and everything else blank. So let's bring that formula into our table and see if we're able to identify outliers. So if we look at this, we know that anything above 3,230 is going to be a outlier. So we can look through our data and we don't see any values that high except the last value. And we know that the minimum value is negative and we don't have negative users to our website. So that might be not the best method to calculate our outliers. So I have modified the formula to fit our data set. And I can have a sensitive outlier formula. This is a little bit different, but let's go through it together. So here's my limit, my top limit. I'm using the same percentile iterator formula. I'm saying give me all the data, regardless of filters, but I am using the 95th percentile and the 10th percentile for my lower limit. And I'm saying anything that is above the 95th percentile is an outlier, and anything below the 10th percentile is an outlier. So we're not using the traditional formula, but however, we're still able to identify outliers in our data. So let me bring that in to our table. And we can see that we have a lot more outliers identified here. And we can see all this falls under our definition. Now, ultimately, we might want to give the user the ability to change the threshold. So above 95 or below 10, we might want to change that to make it more sensitive. Change this to an 80. We might want to make this lower than the 5th percentile. And we can definitely do that as we did in our dynamic data set. So we can see that we have this sensitive threshold where we can change the upper limit and the lower limit. And then we can see how the days in range change. And let's see how we create this. Now that we have our sensitive outlier formula, we would want to give the user the ability to dynamically change that. But first, let's visualize our data. If we plot out all of our data, we would use the date, and we would use our outlier data, and then we would not summarize. Then we can see all our values. And let me close this a little bit so we see it a little better. Then I want to say we can see all our values. But to identify the outliers here, we have to take a couple other steps so we can see the outliers identified as red and the other values. So I would want to plot out only the outliers. And we can do that through a filter using the calculate function. So if I duplicate this and I say, okay, I don't want all of the users, so I'm going to take that off, but I want to be able to calculate only the outliers. If I want to calculate only the outliers, we do that in the same fashion. We set up our upper limit, which is a 95th percentile, which I've hard-coded here, and our lower limit is the 10th percentile, and I'm saying give me those two variables and return all the users using the calculate functions, but I want everything filtered only to the things that are above the 95th percentile and below. So if I bring that in, we can only see the outliers according to our threshold. Now the second part of this would be to graph or visualize all of the data that is not an outlier. We can do that by just using a conditional. So if I say if total users equal our outliers, which I have already graphed here, blank it out. Else give me all the total users. So I'm just filtering out the outliers to give me the data in the expected range. If I add that to our visualization, now we have the same amount of values here, but they're broken up to two types. We can go simply to colors, and we can change our outliers to red if we want. And to see this a little bit better, I'm going to change the background to black. Let's eliminate this because we know what we're, and let's make this a little bit bigger. Now we have the outliers that we can see. That threshold that we saw in our formula for only outliers is set at 95th percentile and the 10th percentile. We want to give the user the ability to dynamically change those thresholds. So all we would have to do is create a parameter. And let me quickly walk you through how to create a parameter. You would go over to the modeling tab. You would click parameter. We would set our minimum and maximum. We would probably want to be above the 75th percentile. Now we only can put whole values here, but I'll show you how to turn that into a decimal in a minute. And the maximum, maybe we would put 95. Increments, we could go by 5. And if I hit OK, it adds a slicer. So I've already done this. For our top percentile, it generates a series. We know the 75th percentile was where we wanted to start. We went to the 95th percentile and we have increments by 5. That gives us the ability to add a slicer here. Now that slicer does nothing unless it's connected to a formula. Now remember, we have whole numbers, but we want to turn that into a decimal. So we have our whole number here. This is the selected value that is default when you create this. And then all I did was divide it by 100 to get my higher percentile limit. I did the same with another parameter where I said anything under 25th percentile. We are starting at 5 and going by increments of 5. I did the same thing by getting that parameter value and dividing it by 100 to get the lower parameter limit. Then I can go over and create a formula, same as we did here, where we are only looking at the outliers, but instead of having this hard-coded value, I am going to have a dynamic value there, where I have entered that higher percentile limit and that lower percentile limit. And what that does is gives us the ability to dynamically change this. So let's sub out only outliers to only dynamic outliers. And let's get the proper parameter. So right now we can't see it because we don't have our parameter there. Now that we have both parameters there, because that we can easily see let me put both parameters there. We can easily change, and let's turn that back to red. So for our outliers, only dynamic outliers, we want red. And now we can easily change that where it picks up more outliers after we dynamically change that. Of course, we can go over to the already finished dashboard, and we can see, once this is properly visualized, how those dynamic parameters allow us to identify more or less data that falls outside of that parameter value. I hope that helps. Thank you.